include the shear deflection if we wanted to. So the hint that we're going to be looking at shear deflection is there. Okay, so now if we want to include the shear deflection, then we go back to our general expression for the internal virtual work, and this time we want to, there's no axial force in this example, so we've got major axis shear and major axis bending. So we're going to be including both the V component as well as the M component. So now the other tricky bit is that it asks you for the slope. So it wants both the deflection and the slope at the support. So the question asks, what is the deflection at that point? And the question also asks, what is the rotation or the slope at the support? So there's two things that we're concerned about, delta and theta. So that's no big deal. Let's go back and look at the notes, and back on where it says the unit load method, we can either apply a unit load, or if we want the slope, we apply a unit force, and that will give you the slope theta. So going back to where we were, if you want the deflection at the center, stick the unit force at the center, and if you want the rotation at the support, stick a moment at the support. Okay, so these words are very general. So if we want the deflection at, which we do, if we want the deflection at that point, we've got to stick a unit force at that point, and if we want the rotation at the end, we stick a unit moment at the end. Okay? So let's have a look at the solution. So there's the problem. Firstly, you've got to plot the bending moment diagram, and you've got to plot the shear force diagram, and don't worry about sign conventions or worry about them, but just assign whatever you want to them. So we've got shear and we've got a sagging moment. So if we want our deflection, we stick a unit force at the center, do our integrals, which I'll talk about later on, and when we solve our integrals, we can use Appendix 2 or Appendix 3, and out will come your deflection, which we can see there. And when we want our rotation, we stick a unit moment at the end, and we go through a similar process, and you will get your rotation coming out. So your homework is to do that question, and I'll see you on Wednesday.